What we think of snow depends a lot on where it falls. If you live in the eastern US, maybe it's fun. Or maybe it's just a pain.
But if you live in parts of the world where they depend on the water that's in the snow for a large fraction of their total water that they use for drinking, for agriculture, for industry, or for hydropower, the snow is a very important natural resource. For example, in the western part of the United States, 80 to 90% of their renewable water comes from snow.
Snow is one part of the cryosphere that many of us have actually encountered before, but it also plays a critical role in regulating the Earth's climate. Through decades of remote sensing, NASA has kept a close eye on the ebb and flow of snow cover.
We now have a 52-year record of snow cover in the Northern Hemisphere, and we can see changes in the extent of snow cover over the time period, particularly in the last few decades, where we can see that the snow cover has been retreating. It's been melting a lot earlier in the springtime.
The extent is relatively easy to do, and it has been done over the years. What's tricky is, though, how thick is that snow? And it's even trickier how much water is in that snow.
That tricky part is known as the snow-water equivalent, or how much water would actually be in a layer of snow if it melted. NASA and its partners have taken to the air to help solve this elusive mystery. First, there's the Airborne Snow Observatory, or ASO, a small plane outfitted with a couple of instruments, one of which measures snow depth using LiDAR. LiDAR measures distance using light from lasers. Since 2014, ASO has flown over basins in California and Colorado, taking before and after looks at snow depth. Scientists subtract the snow-free summer data from the snow-on winter data to get an idea of the snow depth. There's no single way to measure all types of snow across the globe, and so NASA's other airborne campaign, SNOWX, is testing different combinations of sensors. This winter, SNOWX will test a new instrument, the Snow-Water Equivalent Synthetic Aperture Radar and Radiometer, or SWISAR.
SWISAR consists of two main components, one of them being the radar and the second one being the radiometer.
So with the radar providing the depth of the snow and the radiometer providing the density of the snow, we could put those two things together and get the snow water equivalent. Here in the chamber, we're going to measure different radiation patterns at our different frequencies and do some full system testing in this chamber. This chamber kind of enables us to isolate various types of radiation and interference. And in about a month, we're going to take the instrument, mount it on a Twin Otter in the Grand Mesa in Colorado, and we're going to fly it over the Grand Mesa and take various different measurements. This is what we call our engineering flight.
Making sure the sensors are calibrated is key in order to face the challenges nature will throw at them.
Half of the area that gets covered by snow every winter contains trees and forest. And the trees make it difficult for the sensors to see the snow that's underneath the trees, so it makes it difficult for us to measure how much snow there is. After the snow's had a chance to sit on the ground for a while, it gets denser and denser and denser over time, and it changes, which is another reason why snow is very challenging to remotely sense. It doesn't stay the same, it's constantly changing. One of the things that we often do in the field is go dig what we call a snow pit. You literally dig a pit in the snow so we can see all the different layers. The layering is very important.
All this digging is part of ground truthing SNOWX, a way of matching up what the airborne instruments see and what is actually sitting on the surface. The ultimate goal of SNOWX is to figure out what the best combination of instruments would be for a future satellite mission in order to get a global picture of snow.
We need to know how much snow is in a snowpack, because if we have too much snow and the snow melts too fast, then you can get flooding. And if you don't have enough snow, or if the snow melts too early, that can lead to a longer wildfire season, a more intense drought, and we need to know these things for water resource planning.
After After we had a record that was about 15, 20 years long, we started noticing that the extent of the ice in the Arctic was getting smaller over time.